This question can be a little bit confusing if we're not too sure what it's exactly talking about. So we'll get into it. Starting from d sine theta equals n lambda, derive an expression for the intensity maxima, that's an important part, of the atom waves diffracted through the double slit as a function of kinetic energy. So function of kinetic energy, that's also important. Now, what confuses me about this when I'm looking at the question is I don't know what the... I recognise it's a formula, and I'm trying to come up with a formula that derives from this. But I can't for the life of me work out a variable for the intensity maxima. Is it I? I for intensity maxima? If so, that doesn't appear anywhere in any of the equations that I know to do with this experiment. What it's actually talking about is it doesn't want a particular I equals something. It wants you to start from this equation, d sine theta equals n lambda, to derive an expression for the intensity maxima as a function of kinetic energy. This here is an equation which is an expression for the intensity maxima, but it's a function of the wavelength, not the kinetic energy. So we have to combine this plus our formula that we worked out previously for the wavelengths. Remember, the wavelength equals Planck's constant over square root 2me. So that formula there, or let's circle it so you can see what I'm talking about. This formula here is the wavelength as a function of kinetic energy. This formula here is the intensity maxima, an expression for the intensity maxima as a function of wavelength. So all we have to do is substitute that in. So our formula will be d sine theta equals, instead of n lambda, it's going to be n times h over square root 2me. It's that simple. But interpreting the question and what this means, not thinking that you have to put I equals something, that's understanding it and working it through. It also helps when you look at it in relation to question 2, comparison, or a contrast, depending how you look at it. State the corresponding expression for the intensity minima. Okay, now the intensity minima expression also uses this d sine theta thing, but this time instead of being n lambda it is n minus half lambda. Remember, when you've got the screen, you've got the central fringe, which is 0, n equals 0. The next one is n equals 1, and the one on the other side is n equals 1 as well. The minima are these bits in the middle, and they are half a wavelength path difference between the two. That means they're going to arrive out of phase. So that's where we get this n minus a half term from, because instead of being a whole number of path wavelengths difference, there's a half a wavelength. They actually talk about an odd number of half wavelengths, but there's at least 1/2 or 1.5 or 2.5, 3.5. That's how you get the odd number of half wavelengths. In any case, we do exactly the same that we did above. For this wavelength part, we just substitute in the lambda equals h over 2 square root 2me. So we'll do that in green this time, and you'll see exactly how it goes. It goes d sine theta equals n minus half in brackets, so that we don't confuse it, h over square root 2me. So again, it looks complex, very simple once you interpret the question clearly.